Good morning and welcome to the second webinar of the Circular Economy series. Today's session on circular manufacturing systems will be led by Farazee Asif as well as Ruud de Bruijckere. Farazee Asif is a senior researcher as well as director of International Masters Program in the Department of Production Engineering at KTH Sweden, and also the co-founder of CirBES, a company supporting the manufacturing industry in implementing CMS. His area of research lies within circular manufacturing systems in the context of circular economy, with great interest in modeling and simulation of complex systems relevant to CMS implementation. Ruud de Bruijckere, VP of Product Development at Signifikant Svenska AB, has more than 25 years of experience within the areas of real-time expert systems, predictive maintenance, and aftermarket information management systems. Both our speakers today are involved in several EU and nationally funded research projects in the area of CMS. While Asif is actively involved in research as well as leading R&D tasks, Ruud and Signifikant are one of the technology partners tasked with developing an ICT platform for a white goods demonstrator. Today's session will take you on a journey from ideation to implementation of circular manufacturing systems through best practices, frameworks, and use cases from the industry. Before we get started, I'd like to inform all participants that your mics will be muted till the Q&A session. If you have any queries in between, please type it out in the chat box or ask the speakers during the Q&A at the end of the webinar. Over to you, Asif.
Thank you, Karishma. Thanks for a nice introduction. So as mentioned by Karishma, so this is a joint webinar by KTH and Signifikant AB on circular manufacturing systems from idea to implementation. So I welcome you once again to this webinar. So I think some of you may have heard about the term circular economy, but certainly not the term circular manufacturing systems. Circular manufacturing system is not different than what circular economy is saying. It is built upon the same philosophy, but by adding manufacturing in the term, we are drawing a boundary and the scope of our work, and emphasizing that we are primarily targeting the manufacturing industry. So our work relates to manufacturing industry in the context of circular economy. So this is the outline of our presentation today. So I will give you some brief information. What are the differences between linear and circular manufacturing systems, introduce some best practices, and then our research finding in the form of circular manufacturing framework. And then I will introduce you to an industrial case. Right now we are working together with Signifikant. It's an EU project. And then finally, Ruud will explain how information and communication technology or ICT can enable in implementing a circular system or become circular. To start with what circular system is, we need to understand what a linear system is. So briefly, a linear system means that you take resources from Earth and use those resources in different manufacturing processes to make goods, and then use those goods in our everyday life to fulfill different purposes, and when we are done, we dispose those to the nature. And this is the approach industries are using for centuries, and it is built upon the assumption that resources are infinite, and the waste carrying capacity of the nature is also infinite. But we all know neither of this is true, and linear system is not sustainable. Now there are different evidence. Now, if you look at the world population, and even if we go for a very optimistic extrapolation, the population that we'll have in future is demanding a lot of resources that we do not have. So resource scarcity due to overconsumption by this growing population is not a myth anymore. And if you look at this graph, it shows that there's already an evidence of resource scarcity. The commodity price is steadily increasing since 2010. We are emphasizing that resources becoming scarcer, and this is an evidence. A similar trend is seen in price volatility when it comes to commodity, which also shows that in last 2 decades the price volatility of necessary supplies that is necessary for prosperity is getting more volatile. And this is also another sign of scarcity. And it shows that in one side we are consuming resources as the population is growing, and at the same time we are creating some uncertainties in terms of getting the supply of necessary resources for our prosperity. Now, what is the way forward then? So how do you deal with this issue of resource scarcity and price volatility, etc.? So at least to us, the way forward is the circular manufacturing system. Circular manufacturing system, which suggests that after products are being used, they are brought back and they are reused as a whole when it's possible. And if it is not possible to use the product as whole, then we combine, we recover parts from products and then combine them with newly manufactured components to remanufacture the product. And if reuse and remanufacturing is not possible, then we do material recovery through recycling. And this is basically the idea of circular manufacturing system. Prioritize reuse and remanufacturing process, and when it is not possible, then we do recycling. Now, as you can imagine, reuse can be done making a shorter loop, perhaps without involving any industrial processes. And as a result of this, the value recovery is highest, and as well as conservation of resources is high. Remanufacturing, on the other hand, involves industrial processes. It requires additional resources to remanufacture a product, and also, which means the resource conservation is a little bit lower than reuse. But on the other hand, the product that it brings out after remanufacturing is way more good quality. It is as good as new. So remanufacturing is a well-established process when it comes to ensuring high quality with minimum resources. And recycling is a process of material recovering. So this is the last resort that we suggest. So if you want to conserve resources, we need to prioritize reuse and remanufacturing, and when it is not possible, then we recycle to recover value. And this is what a circular economy or circular manufacturing system is in our context. Now, apart from this, resource scarcity and environmental aspect, there are economic potential for industries to tap. So studies have shown that up to 90% value of a used product can be recovered in various ways of value recovering processes. And if you look at manufacturing automotive industry, there are studies which shows that in some cases, in many cases, automotive components from automotive components we can recover embedded value in this ratio. For example, in some automotive components we can recover 88% value that is embedded in the product as labor, and 85% plant and equipment, 80% material and energy. And these numbers are not just, the outcome of research projects and on scientific paper. There are best practices. There are evidence that companies are capitalizing the possibility of the potential that I just have mentioned. Now, these are some best examples that I sorted out. So from manufacturing industry, automotive industry, we have Renault that is remanufacturing a wide range of automotive components, and by doing so, they're recovering quite a lot of resources, and they are being able to offer products which are 50 to 70% lower price than new products, new components. And through these activities, they are creating revenues of $270 million annually. Then in the bottom, we have Caterpillar that is remanufacturing heavy machines since 1973. They're also being able to offer products 30 to 60% lower price after remanufacturing in comparison to new products. And by doing that, they have recovered 154 million tons of material in 2015, and 18% of revenue is coming from these activities. In electronics industry, we have Ricoh and Xerox, who these companies are also doing similar activities. And you see that in case of Ricoh, 170,000 copiers were collected in Japan in 2014. And by doing that, input of new material reduced by 8,900 tons, and their green line, product variety has a rapid growth, which started with 5% in 2012 and 13, and now is up to 20%. Xerox has also asset recovery program since 1984. This is the similar example. As I mentioned, it saves a lot of material, energy, CO2 emission, and water consumption, etc. So despite of having such a good outlook from both economic and environmental point of view, unfortunately, the remanufacturing intensity in Europe is very low. So if we compare it with new manufacturing, it's only 2 washing machines are being remanufactured in comparison to 100 washing machines are manufactured, which shows that we are not tapping the huge potential that we have. So this let us think, okay, what are the problems hindering the industrial uptake of reusing and remanufacturing, and how we can facilitate this better? And then we did research on this topic since we are doing this research in this topic since 2010, and our research finding can be summarized in four points which we call the circular manufacturing system framework. Now, the first point is reuse, remanufacture, and recycling activities are integrated part of the manufacturing systems. We have to ensure this because we cannot just produce products and assume that someone else will do value recovery activity for us. It will not work. The second thing is that we need to design intentionally for reusing, remanufacturing, and recycling. It should not be done by chance, as it is done in conventional approach. We cannot design a product and send it out in the market which is not designed for value recovery, and then value recovery will not work if we not design intentionally. And then the third is that the implementation needs to be done in a wide range of product at an industrial scale, because the magnitude of problem that we are facing, or the challenge that we are facing with resource scarcity, it cannot be solved with 1% or 2% of the market share that is done by remanufacturing activities. We need to scale up remanufacturing activities to the same level as of our manufacturing activities that we have today. And finally, we need to maintain and emphasize on economic and environmental feasibility. No company is going to do remanufacturing on value recovery if it is not economically beneficial for them. And there is no point of doing this if we are harming the environment more than new manufacturing. So these are the four main points that is our framework suggests that we need to make value recovery part of our manufacturing system. We need to design for it, we need to implement in an industrial scale, and we need to emphasize on economic and environmental feasibility. Now, our research has also shown that for a company to become circular, a systemic and systematic approach needs to be taken. And they need to work with several areas of businesses. Now, the first thing that we need to work with is the business model. Conventional sales model is more likely to fail if we want to keep control over our product that we want to bring back for value recovery. Alternative business models such as leasing or service function-based business model, where function of a product is offered as a service instead of product as a whole, is more appropriate for this sort of circular system and retain ownership. Now, once you have designed a business model that is more appropriate, then you also need to adapt the product design accordingly, because the product that is designed for sales purposes will not work for leasing. In leasing, you need more robust product, because you do not know how the consumer will treat your product. As you may have heard the expression, people say that the fastest car in the world is the car that is on lease. So you need to consider this, that when you change your business model, the product needs to be designed accordingly. And once you have business model and product design, you also need to make sure that there is a proper supply chain in place, which will allow you to bring back the product and then send the product back to the market several times. And to manage that, you need to have a proper ICT infrastructure that will allow you to manage product, its services, and also stakeholders that are involved in this. Now, what I said so far is outcome of our research, and it is more or less in theory, but it is not validated unless we do an implementation of the idea. And as part of implementation, we are working with product service offering as a part of European project. So what product service offering means is that in the context of circular manufacturing system, we want manufacturers to exploit product service offer, which means making the functions of a product available to a customer instead of a product itself. Now, in this example, it means functional or product service offer means that a customer is in need of a quarter-inch hole, not the drill or the drilling machine. So the function that the drill is providing is of interest, and circular economy suggests that, okay, if we can make this function available, then we retain the ownership of the product with us, which will allow us to recover the value in a better way. So, having said what circular product service offer means, we move on to the next slide, which says there are a range of business models that we can work with in order to maintain ownership of products. Now, in this case, there are three main type of business models that can allow us to retain ownership of the product. One is buyback, and the other one is leasing, and then functional sale, which is pay-per-use, so to say. Now, these are the three major type of business models that we work with, but there are a couple of them in between. Now, we suggest to go for functional sales, which is more appropriate for circular manufacturing systems, but it also brings out some challenges. For example, if you go to pay-per-use model, the desired level of service level for customer will be higher, so customer will expect more service from you. This also means the operational complexity will also increase. So that means if you move from linear to more circular business model, more complexity will come. Now, as I mentioned, so the research is not complete unless we do testing in industrial case. So right now we are running an EU-funded project, which is called RECIPS, which stands for Circular Resource Efficient Circular Product Service Systems. And this is a Horizon 2020 framework funded project. In the project, we have two industrial demonstrators or showcase that we would like to bring forward as the success story. And one of the case company is Gorenia, one of the leading home appliance manufacturing company in Europe. And the product that we are working with is a washing machine. Now, among other things, the higher level objective of this the project or the case study is to implement 300 washing machines with paper wash offering in 4 European countries. And as part of the design, would like to develop a long-lasting smart washing machine that is robust, but can also communicate through internet in real time. And we are also uptaking a challenge that the same machine will be refurbished at least twice to serve 3 life cycles, where each life cycle is 5 years. So what we are trying to do in this project is validate or test the framework that I have just presented. Now, you can probably already imagine that when you go to this sort of business model, it becomes complex, and suddenly the manufacturers need to answer a lot of questions that are perhaps not that relevant in case of conventional business model. For example, you need to know how is the machine doing, when to do the next service, what type of service needs to be done. where is the machine, how much should I charge the customer, and the customer would like to know how much I need to pay, and etc. So these are the questions that are usually not very relevant in case of conventional business model, but suddenly becomes very important. And this answer to this question needs to be available in real time, which puts additional demand on our system. Similarly, the collaboration among different partners becomes extremely important in this business model. So inter-organizational collaboration is one of the keys in success of the circular system. And as you can imagine, when you have this sort of business model, then you need to ensure that the partners are collaborating properly. For example, the logistic companies know when the products needs to be brought back for remanufacturing. The service personnel knows when to go for service operation and make sure the product is not breaking down. So this sort of collaboration is needed. So the complexity in product and also the complexity service needs to be handled with. And our way of handling this is what we call the information and communication technology. And we see this as an enabler of circular system. Now, my colleague Ruud will take it over and he will explain a little bit more on how, in this case, we are using ICT as an enabler. Thank you from my side.
Thank you, Asif. And hello, everybody. Yes, I'm Ruud de Bruijckere, and I will talk about ICT as the enabler. Asif has been talking about how to move from a linear manufacturing system to a circular manufacturing system. And this involves a lot of work. The subtitle of this webinar has been From Idea to Implementation. And implementation includes a lot. You have to change your organization. You will have to change the way you design your products, your logistics organization, your business models. And that all of that involves also changes to your ICT system. The goals that we put on our products and on our business processes, or maybe we should say challenges, are a lot. We want to implement new business models, circular economy business models. We want to use the products longer. We want to use them in a better way so they have less impact on the environment. We want to give these products multiple life cycles, so they are not just used once and someone is not happy with it again, they are thrown away or recycled. No, they are reused, refurbished and reused. And all this will require a collaboration between the organizations in your company. So if you look at these challenges separately, if we look at the business models, we have, for instance, a pay-per-use model. What does this have for impact on your ICT system? As soon as you are giving the possibility to use your products pay-per-use, then you will have to know where is the product, where is the device. It should be connected. You should be able to monitor its use. The use information should be fed back to the backend system so that we can create a bill and send to the user. So this will create a need for a cloud where all these devices exist and talk to the backend systems. If you're talking about business models like product as a service or function as a service or performance models, then more focus will be on the manufacturer who's still owning the product and has an incentive to make sure that the product is working and is not breaking down. So then the ICT can help with not only gathering the information on the usage for billing, but also for training a neural network, building up a huge big data information database, and predict when a product maybe is going to go down, and send out service technicians for preventive maintenance, predictive maintenance. If we look further on the longer use of the products, to extend the use, this will mean that products will also be repaired and maintained more often than they are today. We will not plan for, instead of reparation, to buy a new product. This means also that in many countries, reparation and maintenance is very expensive, because the service technician has to come and enter the door, and then already it costs maybe half of the product price. So we will have to support the owners and the users to do maintenance and repair themselves. And this will put also a pressure on the ICT system to support this with intelligent service applications which have different modes for trained, skilled service technicians and for users who want to do the repair themselves. If, of course, the product is designed correctly for easy repair and maintenance. Augmented reality is an ICT technology who can help here to say, okay, you put your telephone, you point it to your machine, and the machine will appear on the screen, but then also instructions will appear on the screen and say, turn this knob and unscrew this screw, and now you do this and now you do that, to help unskilled users or owners to do repair and maintenance. So this also put a need on the ICT platform. So there was longer use, using the product longer, but we also want to use the product better. So again, there, by collecting information from the user and from many users, and by feeding that into a database, you can also have experts looking at it and provide guidance to the users. Feedback of, you should maybe not wash every time in 90 degrees. You should wash in 30 degrees. We could build smart applications from which you can control your device and give rewards for good use of the application. You could even gamify the use of the product and compare the use to other users and say, well, you're actually right now 5% more energy effective user than the average user. So this also will put a stress on the ICT platform, but we think it can have a big impact. And on top of longer use, better use, we're also talking about multiple life cycles, usage by multiple users. And again, this will put a strain on the ICT platform, because it's not only important to know how much it is used, but also in what way it has been used, and keep track of the product and to see if the product has been changed, if it has been maintained and components have been replaced. So we need to know the as maintained status of our products. We need to know how many kilometers a certain component has been, so that when it comes to refurbish plant, we know what to do with it, if it still can be refurbished or it has really come to the end of life cycle. So this is enormous information need, and this information need also is shown when we're talking about the inter-organizational collaboration, the different parts in the company, the sales, the service, the repair, the users, the marketeers, they all need this information. But we also have our privacy concerns. And we also have our various systems. So the ICT is very much here working on unifying aftermarket data, putting it in one place and making it possible for many systems to use it, but also to unify the information that's in it, so that not different systems call the same thing, the same caller, give them two different names. So here we have a lot of challenges, but also we have enormous lot of possibilities in the ICT area. Asif, if you can show the next slide. Yes, thank you. So, as Asif also mentioned, we need to prove this. We need to do this. We know that the information technology is available, but we need to prove it in real life, and that is where the RECIPS, European Research Project, is part of. That's KTH and Signifikant are part of this project, and the white goods manufacturer Gorenje. And what you see now on the screen is the ICT platform that we have created for a industrial scale demonstrator, where we in 4 countries in Europe will give the possibility to users to not buy a washing machine, but buy a pay-per-use washing machine contract. But it's a generic picture, I think, for the ICT structure that you need for a circular economy. In the middle, you see the device, in this case, a washing machine. It's a smart device. It's connected to the internet. It has a smart panel where we can put, for instance, if you start washing, you can immediately see the cost and the effect on the environment. But it is connected. It's connected to the IoT cloud in the top. Through this IoT cloud, it has access to the backend systems. They are called here other solutions, the economical system, the ERP system, the service portal. And by this through this connection, the economical system can follow the use of the machine and send out of the bills correctly. What you see around the machine, you see a lot of people using the information that is in the IoT cloud, but also communicating with the machine. There we have the applications, web applications, handheld applications, other systems that can control and see the information from the washing machine. Here we can, for instance, have the intelligent service application. Where when a service technician goes out to repair the machine or goes out to gather the machine, can see what spare parts do I need to bring with me, what documentation do I need, and so on. Can be used there. Here can also be an intelligent application, a web application that is used by the user. The user can control the washing machine, but also can, for instance, compare the usage with other usage in the neighborhood or with friends or with all users of the pay-per-use offering. So here we're talking about connected devices connected to the backend systems, the intelligent service applications. We have talked about predictive maintenance in the IoT cloud. We also have support for gathering and storing the information, of course, anonymized, but using that information for learning about the devices, learning what components are often breaking down and why, and what are the patterns that precede the breaking down, so we can warn about machines out there that actually are in danger of breaking down. Then we have the support for refurbish and reuse, and again, this is a lot about monitoring the use, how it's used, how much it is used, keeping track of the machine, and making sure that it is available for the correct users, in this case, a refurbishment plant. So there we come actually at the point that, okay, we're talking about connecting all the devices, keeping all the information, but still making sure that the privacy also is, the privacy concern is taken care of, and sharing this information with different stakeholders, and making sure that each stakeholder can see and use the information that they should, and not more than that. So there we have a task to make sure that everybody sees what they should see, but not more. So this is a quite complex and interesting ICT challenge that we now are building for real for Gorenje, for ensuring that they can have this pay-per-use scenario. And this slide is actually a build-up for our next webinar, where we will go in more detail about this ICT platform, ICT setup that we are creating for this pay-per-use industrial scale demonstrator. I think with that, I will leave over back to Karishma to shortly summarize what we've said and open up for questions, and also, I think, tell about the next seminar. Back to you, Karishma.
Thank you, Ruud. Thank you, Asif. Thank you for sharing the essentials of this transformation, the necessary steps to make this business model transformation through the 5 R's of recycling, remanufacturing, reselling, refurbishing, and repair, and also for sharing best practices, the trade-offs, and the frameworks in terms of business frameworks and ICT frameworks. We have a few questions that were sent to us via chat during the session. So I will pose these questions to both of you, and please take it. The first one is, ICT is the enabler, I agree, but currently most white goods and other machinery are not equipped with sensors and connections. How do you work around on the way to circular economy? People will have to buy new equipment first in order to be ready for circular economy.
Yes, that is, of course, a challenge. The good thing here is that if you take the example of Gorenje, they have decided that, okay, we will do this industrial scale demonstrator, and this will just be limited to, say, 300-400 washing machines. So we have developed an intelligent connected washing machine with a connective possibility. But exactly for tackling this kind of questions, they have decided that every washing machine that will be produced from now on will be have the possibility to connect, so that if this this will be a success, then they can actually all the machines that they have sold before the people have chosen for the pay-per-use option, they can actually switch to it in the future. Unfortunately, there's not much to do about machines already out there, even though maybe I know that there are initiatives of adding connectivity to machines, but I think it will be pretty hard. So I'm afraid there will be a transformation period here. But right now the washing machines don't have, unfortunately, a very long lifetime. They should have much longer. So let's hope that we will get there, that all the machines are open for these kinds of circular initiatives.
Thank you, Ruud, and thank you, Benedict, for the question. If you have any other questions, please unmute yourself and ask away. We have another 5 minutes before we can wrap the session up.
I have a question. In the implementation of a CMS, is it possible to apply this idea in the medical device industry where there are many safety regulations?
Well, I'll take this question. Yeah, I think in principle, it is possible to implement this idea in any industry, but some industry are more strict than the other industry. As you mentioned, medical industry is very picky about safety and so on. But what we know from our research, that if you want, if you do remanufacturing, you can offer the same level of safety and warranty as a new device. So it is possible technically, and it is possible also theoretically. Now, when it comes to individual market, we need to, or individual sector, we need to see what sort of regulation there is and what additional measures that we need to take in order to fulfill the requirement of that market. So in order to summarize, it is technically possible. We just need to see what additional requirement needs to be fulfilled.
Thanks,
Asif.
Asif, my question is to Asif.
Yeah.
Yeah, so how would you comment on the grade of the recycled material? Like, is it as superior as the original raw material? And does this prevent the manufacturers from remanufacturing or recycling the product?
in the current settings, the recycling that is happening, in many cases, the quality is not superior because the remanufacturing is recycling is done in a way where the true identity of material is being lost and it is being combined with other similar material. But if you think about it, I mean, if you think about an industrial scale implementation, then you can also think about closed loop remanufacturing, closed loop recycling, which means that, for example, the Scania product will be recycled by Scania to maintain the purity of the material. Right now, it is not possible because I was interrupted. Sorry. It is not possible because the technology that we have for recycling is not dedicated for one individual product or one individual company.
We have another very interesting question by Benedict again. How do you make sure people are motivated to use the circular economy business model? Is it not an idea of a small fraction of people in a bubble of highly developed economies?
Yeah, that's a very good point. It is, you can say that way, but if you look at developing countries, circular economy in developing country is part of their life, and that is a necessity, right? We are not talking about circular economy the same way as we are saying here in Europe, in India, or in Bangladesh, where I am from, but we are doing it. Now, it is a matter of motivation at this point, but soon it will be a matter of necessity. So we will have to do it, and I'm convinced that the market will respond to this, changing climate and also resource scarcity and so on. At this point, it is a matter of motivation, but in future it will be a matter of necessity, I believe.
A short follow-up question on this one. Thank you for the answer. But would you not have to implement or also consider in the system in itself, now that you say it's a matter of motivation, to actually induce the motivation in people and not just wait for resources to be too scarce and too expensive to have to recycle them?
No, that's true, and this is what we are saying through this business model transformation. So we are trying to make it, the function of product more relevant to customers than the product itself. And to do that, you need to bring out with additional value proposition to the product, as Ruud was saying, and I was also mentioning that when you go for a new business model, suddenly the maintenance or service of the product is not anymore the concern of the customer anymore. So the manufacturers themselves have to make the service available, high quality service available. So that's a motivating factor. So you get convenience on top of the service that the function that you are getting. So implicitly you are motivating through business model and through business model innovation and also additional value proposition. So it is already part of our framework, but we are not saying as a it's not a campaign from Gorenia, for example, that okay, we are doing this for environment, because we think this is something that some other people should do, like policymakers, like European Union will do. So from the Gorenia point of view, or a manufacturer's point of view, it is the value proposition that will change the behavior of people, and that's the way we should transit to circular economy.
Thanks.
We have another question that was sent to us. It says, in the implementation of CMS, is it possible to apply the idea in medical device industry, as there are many safety regulations?
I think I respond to that question once again. Practically and also technically, it is possible. but different sector has different regulation. So when you are implementing this, you need to ensure that the requirements of that sector is taken care.
We have time for another 1 or 2 questions before we round off, as we already seem to have run over time. Please ask away right now, and any additional questions, you could get in touch with us via email. An email will be sent to you at the end of this webinar with a recap and a place for you to rewatch this webinar, and also the contact details of Asif and Ruud.
One question on the logistics behind the ownership moving away from the customer to the companies. When you're looking at maintenance and repair, and for example, sending service personnel to the customer to repair and have predictive maintenance, kind of, as Ruud mentioned. Do you see this feasible for a country like Sweden, or maybe also Germany, where people live fairly widely distributed on the countryside? I mean, I see it very feasible in the city, where you have a densely populated area and there might be lots of products that you can service. But once the people move out further afield, is it still economical? Is there any consideration of this as well?
Well, this is a very good point and good question. We are not saying that the infrastructure that is needed is ready yet. There are a lot of challenges, as you mentioned, one of them. But I think in long run, it might be possible to decentralize this service. For example, we are talking about ICT platform that enables multiple users to log in and get information. Now, let's say someone is using in north part of Sweden a washing machine, so we don't need to send a service personnel from Stockholm or nearby big city. Maybe there is a technician, freelancer already in north part of Sweden who can get access to that information and go and do this repair in-house. There could be other solutions as well. This is just I'm thinking out loud.
Asif, we're not able to hear you. No, I think your mic is muted. Could you? Yeah.
Okay, sorry. I think my answer did not go to you. So once again, the question was very interesting. And to summarize, I mean, we are not claiming that the infrastructure is ready already. We have a lot of challenges, and we are trying to solve it through different ways. One of the solutions, as I mentioned, is the ICT infrastructure. Because if you have an ICT infrastructure, you can decentralize the maintenance and repair service. So to give an example, if someone is living in a remote place, you do not need to send a service personnel from nearby city. Maybe there is an expert person within the neighborhood who can get access to the information and do the service that is needed.
Thank you, Asif, and thank you all for the question. We're sorry we've run over time, and I know there are some more questions that are unanswered. We will reply to them via email, and if you have any other queries that you'd like to shoot to us, please respond to the email that you will receive in a few minutes. Thank you again for being part of this webinar. Thank you, Asif, and thank you, Ruud. And we will have a follow-up session in the next 2 to 3 weeks on the actual ICT platform that's been implemented for the white good demonstrator. And we will also have somebody from the white good demonstrator company to talk about the implementation from their end. So it would be the real practical implementation of the system that we have spoken about in the last 2 sessions. Thank you very much, and have a great afternoon ahead.
Thank you, Karishma, and thank you all participants.
Thank you. Bye.
Thank you. Goodbye.